Hi, Professor. I'm going to explain. My name is Gaoyuan Huang. I'm going to explain my homework. So the first assignment is to implement the cost function, and the first one is cross entropy derivative. Just follow the formula. Yeah, use a and y, and because there's gonna be some infinite value, and I just set it to 0. And the second one is log likelihood. I just got the first get the correct label and its index, and then calculate the log likelihood of that, the probability of that index. And the derivative is the same. Just follow the formula, and you first get the index, and make a new numpy array to store the value -1 over its probability. And um, the third one is softmax activation function. So I just follow the formula to take the exponential and make it divided by the sum of exponentials. And this one is just for the numerical stable purpose. And the um, yeah, this one has been implemented by the professor. And for tanh, we just use the numpy function tanh. So it's very easy. And for derivative, just follow the formula, make its square of it, 1 minus square of it. And for ReLU, it's very easy. Just set anything over below 0 to be 0 and return. And its derivative also just set greater 0 to be 1, and by using the just numpy's function. And then it's the tanh warning. So let me see. Accept. Yeah, here. So we set the warning first in the init function when the cost function is not quadratic cost, and the output is tanh, which set this, and make explicitly make it to quadratic cost. And I think there's another place, right? Yeah, yeah. So the second place is set in set parameters. We also explicitly set the cost to quadratic cost when the activation output is tanh. And next one is L2. So first for L2 and L1, we should do it in the updates the main batch, because we are accumulating the delta of weights. So we need to add them by its derivative here for here and here. I just follow the formula the professor gave. Yeah, just do this. And so for implementing the L1, I made a function called sin w to get the 1 and the -1, because its derivative is it's the, I mean, yeah, to get the 1 and -1, follow the formula we have on PowerPoint. And there is another place for this, I think. Yeah, it's in the total cost. We also need to add the L1, L2 to it. And it's also just follow the formula is square, and this is just a sum of the absolute value. And the last one is drop out. We only need to modify the backprop, and the only thing, so I set a condition here. If the dropout percent is greater than 0, then I will go into the dropout. Otherwise, I will not. I just do the same. So for dropout, I just created a mask list to store the masks. I just first use the binomial random binomial function to get the masks, and for then we iterate every weights and biases and masks, and we if this is the last layer we do nothing, but on other layers we will multiply the activation function with the mask, so we can drop out some layers. There's also one minor thing I forgot to say is for the activation output, we need to explicitly set it when we are on the last layer. So we need to have an if condition here when we have the feed word. And also I think in the feed word we'll also change that. Yes, we need to set this. So here is the demos to confirm my code works. So this is just use the teacher's startup application code. So I just run the simple example here, and everything works. For the you can see the all the function works here. What's other log likelihood? So yeah, all other things works, and so just go through all the examples, all the experiments, so it will proves my implementation is correct. So we will load this, and yeah, it runs. The result is the same as the professor's, and yeah, so everything runs well. And the log likelihood, cross entropy, and yeah, and here, yeah, and yeah, all the activation functions and the most functions, and this is the with L2 regularization. It also works. You see here, yeah, and this one's L1. It also works. And this one's with dropout. This also works here. Okay, thank you.